Okay, welcome back. So in this video we're going to be graphing the solution set of this system of inequalities. And so we're going to be doing that with these ones. Sorry. So we've got negative x squared plus 7. And notice these are already solved for y. If they're not solved for y, you'll want to do that first, or at least if it is be able to know what type of equation you're dealing with, what the graph will look like. Sometimes if you have x squared plus y squared on one side, that's going to be a circle. Okay. In this case, I just have x squared. So this is a parabola, right? And it's solved for y already. And it's up 7. So 1, 2, 3, 4, 5, 6, 7. We're up here. And then since there's a negative up front, this is a transformation, so it's flipped upside down. I don't know exactly where it's going to go here, but just sketching a general idea. Okay, it should be filled in because it's equal to. Then y is less than or equal to negative x plus 5. What's the graph of that, the boundary, going to look like? Well, we're going to be y-intercept of 5, so 1, 2, 3, 4, 5. And then slope of negative 1, so over 1, down 1. So something like that. Okay. And so far, right, y is less than or equal to this, so we're going to be below the parabola, so down in this range, okay? And then we're also below this line, so right now we're living right in this region right here, okay? So that's where we are. And then y is greater than 1. Well, y is equal to 1. Looks like a horizontal line like this, right? And so y is greater than 1. Oh, and sorry, it's strictly greater than, so it's a dotted. Should be dotted, okay? And so the shaded region is going to be, we're above that line, below this one, and below the parabola. So where all of those happen is right here. This range in the middle between them all. Okay. So we graphed the system of equations, or system of inequalities. It also told us that we wanted to label the vertices. So remember that the vertices are the corner points of this shape. So there's vertice here, there's a vertice here, and then there's vertices here and here. Okay. Now technically these vertices aren't included in the shaded region because they're on this dotted line. But I would still label them. But anyway, so how do we figure out where these points are? Well, to figure out these two, you'll notice they're both the intersection of this line with this parabola. So what we're doing is we're really dealing with a system of equations of, well, now y equals negative x squared plus 7. That was the parabola. And the line was y equals negative x plus 5. Okay? So to figure out what these 2 points are, we just solve the system of equations. Okay? Can you see that? There's kind of a glare there. Okay, there we go. So let's go ahead. We already have them solved for y, so we may as well just do a substitution. We'll plug this y into here, and we get negative x plus 5 equals negative x squared plus 7. Then I'll get everything to one side, so I'll add the x squared over and subtract the 7. So we get an x squared, there's a minus x. Subtracting the 7, we get a minus 2 is equal to 0. Okay, so I added the x squared over, and then I subtracted the 7 to both sides. Okay? So now we just want to solve this for x, so we're going to factor it. We want things that multiply to negative 2 and add to negative 1. So it should be x minus 2 and x plus 1, right? When we do those, we're going to get negative 2x and plus an x, which would give us the negative x, and then negative 2 times negative 1 is negative 2. So we've got the factored form. So then the two solutions are x equals 2 and negative 1. Okay? So then to get y for these, what we just do is we plug these back into either of those equations. So y, when I replace x with 2, we get negative 2 plus 5 is 3. And on this one, y, when I replace it with negative 1, we get negative 1 is positive 1, plus 5 is 6. Okay? So our 2 points, this one's at 2 and 3, and then this one is at negative 1 and 6. Okay? And you can tell which is which just based on kind of the location of the graph. Okay? So that was us finding those two vertices. Now we just need to find these two. Okay? And those were from this line, the y equals 1 line, and the negative x squared plus 7 line. So we're going to set up a new system of equations. Y is equal to negative x squared plus 7, and y is equal to 1. Let's see, we'll maybe do it over here. I have space. So y is equal to negative x squared plus 7, and then y is equal to 1. We're going to do a substitution, so we get 1 equals negative x squared plus 7. Subtract over the 7, so we get negative x squared is negative 6. And then we just times by negative on both sides. X squared is 6, and then square root. So x is plus or minus the square root of 6. Okay? And we already know what y is. Y is 1 here. So my 2 points are, we've got this one is a positive square root of 6, and y is 1, and this one is a negative square root of 6 and 1. Okay, so we've now been able to label our vertices here for this feasible region. Okay, so hopefully that helps with this. There's a few more of them for you to kind of practice on, but this is the last one I'm going to do. Hopefully that's helpful, and I will see you guys in the next video.